Hello and welcome to this tutorial where I will show you how to use vHelix in combination with our new scaffold routing software to go from an arbitrary polyhedral mesh into a DNA nanostructure design. And I will show you how to design staples and how to assign these with a sequence from a scaffold strand and how to export these sequences for later production. So this process has three main steps. The first step is to create the mesh in a computer graphics software. This mesh is then exported and run through our scaffold routing software, where a scaffold routing is found through the mesh. In the third step, this routed scaffold is exported back into vHelix, in our plugin to Maya, where the final scaffold and staple design is produced and a sequence is assigned and exported for all the staples. So before I start this design, I will go through the software components necessary to follow this tutorial. First of all, you need Autodesk Maya running our plugin vHelix to do the design. Other than that, you need the scaffold routing software available from vhelix.net. This scaffold routing software is packed into a compressed archive, and you should extract this into a folder of your choice, and it then contains a number of files that is necessary for this. In addition to this, I will use an extra piece of software called Mesh Converter, which is available from this website, to convert the exported meshes into a format that works with our routing software. This is not necessary if you do your initial mesh generation in a software that can export to the PLY format, but I will do the first mesh in Maya that does not support PLY export, and I will show you how to do this. So first step is mesh generation, which I will do, as I said, in Maya, and I will first create a new scene to start. So now we have a new scene. And one thing that can be really useful when you're designing a mesh in Maya is the polygon heads-up display. And if you don't see this, you should go into Display, Heads-up Display, and check Poly Count. Then you should be able to see this. Especially edge count is very important for finding an appropriate size of your mesh for the DNA design. So I will start this by going into Polygons. I will have to set this menu to Polygons, which allows me to go into Create, Polygon Primitives, and here's a number of useful polygon primitives that you can use for designs. And to follow this, please turn off Interactive Creation. So I will create the ball that I showed you earlier, and I do this by going into the square here next to Platonic Solids. And this ball is based on the icosahedron. So I'll select that. And I will put the radius to 4. Now the size is not super important at this stage, and you can rescale it later as I will show you. So this is an icosahedron. It's a simple spherical mesh with 30 edges. So this is a bit too low edge count for us for a design from an M13 based scaffold. So I will increase the complexity of this mesh by using the feature Smooth. And again, I will press the little square for extra options. So here I will use the options Linear and a division level of 1. And with the mesh, icosahedron mesh selected, I will press Smooth. Now, this has increased the complexity of the mesh into 120 edges, which is appropriate for us. To perform the scaffold routing on this mesh, I have to first export it from Maya. And with the mesh selected, I hit File, Export Selected. And the ideal format for mesh export would be PLY. Unfortunately, Maya does not support this, and I will show you how to convert your mesh into a PLY format. I will instead export it as an STL file into the same folder where I have extracted my my scaffold routing software, and I will name this mesh ball. Okay, now that I go back to the tutorial folder, I see that I have created a file called ball.stl. Now I need to run first the mesh conversion software and then the scaffold routing software. And this has to be run from command line. So I have to start the command prompt by hitting Wing key R to start the run window, and then I type CMD to start the command prompt. And here I first need to navigate to the same folder as I have my unzipped software. So I will highlight the text, the address, copy it, and then I will go into the command prompt and hit CD and then space, and I will right click to paste in the text the address to the folder. Okay, now I'm in the folder where I have my the routing software and also the mesh conversion software and the mesh file. And I will first run the mesh conversion by typing in mesh conv and then the name of the file, which is ball.stl, and then I will type in the format which I want to convert it to, which is -c ply, and then I will also have to add -ASCII to get in the correct ply format. And now I just hit enter, and now I see that it has written 80 faces and 42 vertices, which is correct with the Maya file. And now I also created the ball.ply file. So now I will also run the routing and physical relaxation software package. And this is done by a single bat file called bscor.bat. And then I will type the name of my new mesh file, which is ball.ply. And then I will follow this by a scaling value, which tells the physical relaxation how many base pairs to put along each edge. And in this case, I will use a scaling value of 1.0. And I will just hit enter. And the scaffold routing is done instantaneously, and then the mesh is moved into the physical relaxation, which is an iterative process and can take a little while to finish, but I will interrupt it by hitting Ctrl+C to get the current iteration out, and then I'll just hit yes to finish this. So now we have created a number of files in the folder here, including ball.rpoly, which is the file that we can import back into vHelix. So now I go back into Maya and again create a new scene for importing my mesh. And now we need to make sure that we have vHelix running in order to do the import, and this can be checked by seeing that you have the Helix menu up here. And if you have that running, you should be able to hit File, Import, and then select your file, ball.rpoly in this case, and hitting Import. Okay, that took about 2 minutes to finish on my computer. And please note that the import process may stop a bit at 99%, but this is just normal. Now, if this import is taking more than a few minutes, this may be due to you selecting too large a scaling value in the scaffold routing and physical relaxation, and thus creating too large a structure. And if this is not what you want, you might consider redoing the scaffold routing and physical relaxation with a smaller scaling value. Alright, now we have our structure inside of vHelix, and we have the scaffold strand here in green and the different staple strands in varying colors. And if we select one of the staple strands, we see its sequence, which is now only question marks, because we have not yet assigned a scaffold sequence. And this is done by selecting one of the scaffold bases, and then going into Helix, Apply Sequence. And then I have the sequence for M13 MP18 in this file. I will just copy it and paste it into this window and hit enter. Okay, now we have assigned a scaffold sequence. And if we again select the same piece of staple, we see that we now have the corresponding staple sequence assigned. And this should be true for all staples throughout the design. So now all we have to do in order to produce this structure is to export the sequence of all staples. And this is done by, without anything selected, going into Helix, export strands. Now this process again takes a few minutes, so I will make a small cut here. Okay, that took a few minutes to finish on my computer, and I now get this prompt asking me where to save the export file. And I will again save it in the tutorial file again. And I will name it export. Okay, if I now go into my tutorial folder, I find a CSV file, comma separated values file, named export, which I can open in Excel. So this file consists of rows, where each row contains the name of a strand followed by the sequence of the strand separated by a comma. And the first line here is the scaffold strand, which I will delete. I will then select the first column, go into data, text to columns, and with delimited I proceed, and I add comma here, and then I can press finish. I have now separated the name of the strands and also the sequence of the staple strands, which can then be sent to your DNA synthesis company. Okay, we have now gone through the production pathway from a polyhedral mesh to a finished DNA nanostructure design. And in the next tutorial I will go more into depth about the design of staples and the other features of vHelix when designing a DNA structure from a polyhedral mesh. Thank you for watching.